Okay, so I think we were in question 10 or something. Can someone remind me where we were last class?
So we
Question 8, I believe.
8A.
Question 8.
A.
Sorry, I'm still struggling. Let me just pull it up here. November 23 homework question. Question 8. Peter plays John at tennis. That one, right? I think we discussed that, didn't we?
So we did only the first part.
Oh, we did only the first part? Okay, all right. Okay, let's quickly do it. Okay. Okay, so intuitively, it makes sense that whenever Peter starts, that's when the probability is going to be higher, right? So let me just paste it here.
So you're not sharing screen.
Yeah. I mean, just a second, I'm going to do that. Okay, all right, we should be set now. Okay, so when Peter plays John at tennis, the probability that Peter wins his service is P, and probability that John wins his game is Q, right? Service game. Okay, when Peter wins at least 2 consecutive games when he serves first. So let's say this is serving first. So this is serving. Okay, let's do the A part also once more very quickly, right? So serving is Peter, then after that John, and then after that Peter. Okay, the serving probability winning for this guy is P, for this guy it's Q, right? And for this guy it's back to P now. Okay, now as far as Peter is concerned, so Peter's outcome. So he wants to win. So this is the game. Okay, so he wants to win and lose, or he wants to win these 2 consecutive ones and then lose here, or obviously if he wins all 3, then he gets 2 consecutive for sure, right? So that answers at least 2 consecutive games out of 3. Let's figure out the probabilities for each of them. For him to win here, it's P. For him to win here, it's 1 minus Q, because it's John's serve. And then for him to lose here, it's 1 minus P. Okay, so very similarly, here it's 1 minus P for him to lose his own serve. It's 1 minus Q for him to win John's serve. And then for his own serve, it's P. So these 2 values are same. Literally, these 2 are same. The product is the same, right? And then this, he wins here with P, he wins here with P, and then he wins here with 1 minus Q. Okay, now we add all of these probabilities. Let's see what they all add up to. When you add all of them, I think I can take P and a 1 minus P common outside for everything. So P and a 1, P and 1 minus Q can come outside, right? P and 1 minus Q can come outside. So P and 1 minus Q can come outside of everything. So if I take P and 1 minus Q outside, in the first expression, I'm left with a balance of additional P. In the second expression, a balance of 1 minus P, I'm taking P and 1 minus Q. Right? In the second expression also, if I take P and 1 minus Q outside, I have a balance of 1 minus P. And in the third expression, if I take P and 1 minus Q common outside, I have a P. Please correct me if I'm wrong, guys, if I'm doing some silly mistake as you're watching this. So it's P into 1 minus Q into 2 minus P. Am I right? Is this what you guys got independently? Navya, is this what you got?
Yeah.
Did it? Okay, cool, nice. Okay, now for the other case where John is serving and then Peter and then John. Okay, so this probability again, the winning probabilities for the serve is as follows. Now Peter's outcome. So again, he wants to win and lose, or lose the first one and then win the next, or all 3 consecutive wins. Okay, sharing is on, right? The recording is also on, right? Okay, good. Okay, now same thing. So for him to win in John's serve, it's 1 minus Q. For him to win in his own serve, it's P. And for him to win in for him to lose in John's serve, which means effectively John wins, that's Q. Similarly, in this one, John wins his own serve, which is Q. Peter wins his own serve, which is P. And then Peter wins John's serve, which is 1 minus Q. And here, Peter wins his own serve with P, and John's serve with 1 minus Q each. Okay, now let's observe all the three expressions. What can come out here? So I'll maybe put it in different color. So I can take P common outside for everything. And then I can also take 1 minus Q common from all the three expressions. There's 1 minus Q here, there's 1 minus Q here, there's 1 minus Q here. So if I take P into 1 minus Q, then what remains inside is a Q in the first expression, a Q in the second expression, and a 1 minus Q in the third expression. So it's P into 1 minus Q into 2 minus Q. Okay, now we are comparing this.
So isn't it just 1 plus Q?
Sorry, you're right. 1 plus Q. So as opposed to the earlier, it was 2 minus P. Now it's 1 plus Q. Good. Yeah, 1 plus Q. Okay, so now we are comparing these two expressions. We are comparing this versus this, right? So if you bring them closer, so then the P and 1 minus Q are, so this is the A scenario, this is the B scenario. The P and the 1 minus Q are common for both. So that's not going to matter. So it's a comparison between 2 minus P here versus 1 plus Q here. Okay, now I can equivalently write that's a comparison between P plus Q here, and 1 here. If I subtract 1, then it's P plus Q here and 1 here. Is this right? Okay, and which means P plus Q is bigger than 1, right? So the second scenario, B scenario, is where you have a better chance. Is this what everyone got?
So but why with this? You can just directly say that P is greater than Q. So then obviously the likelihood that he serves first and wins is higher. Like you don't need these values, right?
Yeah, true. Intuitively, that makes sense. But is the final outcome that? The final outcome is saying what? The final outcome is saying the reverse, right? The scenario B is where there's a higher probability of winning, right? Navya.
Oh yeah.
Right? Yeah. So intuitively, it's deceptive. You might think that Peter has a higher chance, but with the it's because of the way P and Q are. This constraint is very important. P plus Q is greater than 1. For the same problem, had P been like, let's say 0.4 and Q been 0.3, then what you are saying is true. What you're saying is true, right? So whereas if it's, so with 0.4 and 0.3, then P plus Q is less than 1. Had it been 0.6 and 0.5, where still P is greater than Q, but the combination is greater than 1, then it works out this way. So it's a little non-intuitive. Why? Depending on what P plus Q sum would be, the answer would be different. Does it make sense, Navya?
Yes, but
Okay. Anyone else with a doubt, or did you guys get something similar or anything different you want to discuss? Suhani, how was it for you? Yeah, Yuvam.
Sir, I have one question.
Yes, please.
You've written Q in 2 places, right?
In the which expression? The second expression, is it?
Yeah, the second expression you've written Q in loss. Yeah, like here you've written.
Yeah, because here John is serving and Peter is losing, right?
Yeah, so it can also be 1 minus P, right?
No. See, when John is serving, it's either Q for John to win or 1 minus Q for John to lose. It's always from John's perspective, right? Peter's winning probability has nothing to do now. When John is serving, John is under control. Let's say Q is 0.3, right?
So, but when Peter loses, John wins. So it's the same thing.
Yes, but whose serve it is? So during John's serve, it's Q and 1 minus Q. During Peter's serve, it's P and 1 minus P. Yes, the pairs add up to 1 in both cases. One guy wins, the other guy loses, that's for sure. But the combination is different. It's P versus 1 minus P and Q versus 1 minus Q.
Okay.
Does it make sense?
Yeah.
Yeah? Okay. Okay, that was question 8. Question 9. Question 9. Two different numbers. It was observed their sum is even. Okay. Suhani, what did you get on this one?
I wasn't really sure about this one, like how to approach it.
Okay. Arav, how about you?
So I got 5 out of 8.
5 out of 8. Okay. Yuvam, how about you?
So I got 5 out of 18.
5 out of 18. 5
Yeah.
out of 18. Okay. Any other answers? Navya, what did you? I cannot see everyone. Navya, are you there? Oh, okay.
Yes. I got 5 out of 8.
You got 5 out of 8 as well. Okay. All right. Let's discuss. Two different numbers were chosen at random from 1 to 9 inclusive, right? So 1 and 9 inclusive, two different numbers. Okay. It was observed the sum is even. Okay. So what is the probability that both numbers were odd? So in terms of probability, we are saying, what is the probability that both odd, this is conditional probability, right? Both odd, given sum was even. Okay, so that's where it is, right? So right now, when you toss, there are three outcomes possible, right? Both are even, okay? Or an even and odd. I don't mean in that sequence. It could be odd even or even odd. In fact, I'll write it like this: odd even or even odd. Okay, and the third possibility is both are odd. Okay, so let's write out probabilities for each of them. If it has to be even and even, the first one has to be even, the second one also has to be even. There are only 4 even numbers, right? 2, 4, 6, 8, whereas there are 5 odd numbers. So for both to be even, the first one must be even, which is 4 by 9. Second one must be even, which is 3 by 8. Okay, for both to be odd, the first one must be odd, the second one must be odd. Okay, now naturally, this is the subtraction from 1, but let's not subtract. Let's actually do it and see whether the 3 probabilities add up to 1. That way, if there's any mistake, we can catch it. So you understand what I mean, right? So technically, I don't need to calculate this. I can just add the first one and the second one and subtract from 1 and say that's the probability here. But I'm not doing that. Instead, I'll independently calculate this and then verify whether all 3 add up to 1. So that's always better, because if we do a silly mistake in one of them, it'll get caught. Okay, now let's see. Even, odd. So first one must be even. So it's 4 out of 9. Second one must be odd, which is 5 out of 8. Or the reverse, which will be exactly same, right? Odd, even will also be the same probability. Or if you technically have to do it, you'll just do first one must be odd, which is 5 by 9. Second one must be even, which is 4 by 8. Same thing. So this adds up to 20 plus 20, 40 over 72. So I'm keeping everything over 72 so that if I cancel, I have to take common denominator, this, that. Why bother with all that, right? So this is 20, this is 12, this is 40. Now let's check whether these 3 numbers add up to 1. 12 plus 40 is 62, 52 plus 20 is 72. Yes, sure enough, they add up to 1. Okay, so we are good so far. Now, what is the problem saying? The problem is saying given the sum is even, which means the sum is even when both numbers are even or both numbers are odd. That's when the sum is even. So we are given either this happened or this happened for sure. Okay, we are told that this did not happen. So we can forget this even happening. Now we are being asked, given one of these two happened, what is the probability that this happened? In other words, we want to find OO as a fraction of OO plus EE. Right? Right? OO happened or EE happened. Of that, what fraction is OO? That's all the conditional probability is. Right? So that's easy, right? So it's 20 out of 20 plus 12. I mean, I'm removing the divide by 72 in all cases. So, Suhani, does this make sense to you? Okay, intuitively.
Yeah.
Right? Not just mechanically. Intuitively, it should make sense. That's very important, right? So 20 out of 32, which, like you guys said, it's 20 out of 32, sorry. 4 5s are and 4 8s are. Okay, Sanvi, were you able to get the same? Or did you attempt this one? I know you had exams and not well and all that. All okay enough? Were you able to attempt this?
Sir, I got it till that 72 upon 70.
Okay, you got the 3 probabilities,
Yeah.
but after that, you did not know how to do the conditional probability. Is that right, Sanvi?
Yeah.
But now you do?
Yeah.
Okay, cool. Nice.
But I did something different.
Yeah, can you take us through what you did?
So out of 1 to 9 numbers, first there are total में 9 numbers. So I have to choose 2 numbers from 9, right? So it's
Yeah.
9 choose 2.
Yeah.
Which is 36.
Correct.
And you have to, and since there are 5 odd numbers and the 9 numbers, I do 5 choose 2 because I have to take 2 odd numbers. So 5 choose 2 is 10. So I did 10 upon 36.
Which is exactly same as 20 upon 72. For getting 2 odd numbers, it's 10 upon 36.
So then 10 upon 36, then I like simplified it, and that's my answer.
But that's a probability that both numbers were odd. But the question was not, what is the probability both numbers were odd? Question was, given their sum was even, what is the probability both were odd? So you're not using the information that both were adding up to even number. Does it make sense?
Oh, so it
Right?
was,
Which is why it's a conditional probability. You are given extra information that their sum added up to an even number, which means you know for sure this did not happen. This beachwala did not happen. Yeah.
oh, okay.
Yeah. Navya, I had a question.
Yeah, so even I did like a similar method, but I did like out of 4 even numbers, there were 2. So 4 choose 2, which gave me 6.
Yeah.
I see 2 is 10. So I added up 10 and 6, 16. So 10 by 16.
Yeah. So 4 choose 2 is 6. So 6 over, what was the denominator? 36, was it? 6
No,
over
no.
36.
I do 10 plus 6, which is 16. So 16 gives the denominator and then
Huh.
10.
So yeah. So 10 ways of picking 2 odd numbers, 6 ways of picking 2 even numbers. So relatively speaking, it's 10 out of 16. Yeah. Same thing. Okay, cool. That was question 9. Just 1 second.
So how did you get 3 upon 8?
What is the question?
So how did you get 3 upon 8?
3 upon 8. Kahan se 3 upon 8? Which one?
EE.
EE is 12 upon 72.
No, but you did 4 upon 9 into 3 upon 8.
Yeah, which is 12 upon 72, right? So
But
I
how-
said,
Yeah.
okay. For to get an even, I want the first one to be even, and I want the second one to be even. So 4 by 9, right? I've picked one number. That's an even number, right? From the remaining 3 even numbers, I have to pick of the 8 numbers in total.
Yeah.
Okay. Let's move on. Question 10 should be fairly simple. I think we did something very similar last class. Arya, what did you get on question 10? 5 boys sit in 5 rows. What is the probability? 5 seats.
I haven't done it yet.
Why not?
I actually did only to 7 because I didn't know there was a second page.
Okay. All right.
Yeah.
Veer, what about you? Find
So
the
I
problem.
couldn't figure it out.
Why? This one should be fairly straightforward, right? Sanvi.
Even I didn't. Okay, no.
Okay. Did you guys give enough time? I'm wondering. I don't think it's difficult. Arab, your hand is up. Go ahead, please. What did you
So
get?
part A, I got 1 over 10.
1 over 10. Okay, go over. Anyone else got 1 over 10?
Yes.
Even I got 1 over
Okay.
10.
Cool. Okay, can you go over 1 over 10, Arab? How did
Yeah,
you do?
sure. Okay, so it was fairly straightforward, I think. So the total number of probabilities, since there are 5 seats and 5 people, it's 5 factorial.
Yeah.
And then this asks the probability of them sitting at the ends.
Exactly.
So there can only be 2 possible ways. So either
KJ or JK. Yeah.
yeah. So then you can just multiply 2 times 3 factorial, which is the one in the middle, or
Exactly.
the 3 bits.
As
And
easy
so-
as it gets. Veer, does it make sense? Right? For K and
Yeah.
J to sit
Yeah.
at the end, it's either this way, that way, or that way, this way, right? So it's
Right.
2 factorial
Got
or
it.
2. Yeah.
Thank
So fairly straightforward, right? 2 and 3 factorial by 5 factorial, which simplifies to 1 by 10. Okay. Another way I was thinking was, okay, some 2 people have to sit at the ends, right? So there are ends are special locations, let's say there are 5 friends, like let's give others also some number, right? So J, K, let's say the other 3 names are L, M, and N, right? This is J and K. Okay, so there are 2 special seats at the end. So this special seat at the end and this special seat at the end. So let's say those are preferred seats. Some 2 people are going to be picked and they are going to get that opportunity, right? I can pick from these 5, I can pick 2 in 5 choose 2 ways, which is 5 into 4 by 2 into 1, which is 10 ways, right? And if J and K have to be that special pair, it's one of those 10 pairs, right? So it's 1 over 10. Does this other approach also make sense? Dirshit, you're okay on the second approach as well?
Yes, okay.
Okay. Dirshit, by the way, last class, I think you had some specific 1 or 2 doubts. You want to ask them here? Maybe it might be doubts for others as well.
So 1 second, I'll just see.
Okay. Pull it up. Meanwhile, I'll keep discussing, or like anyone, right? So I don't even have to prompt you guys. If you have any doubts from the previous class, bring it to class, right? We'll discuss. Okay. What is the probability they sit together? This again is an approach. Suhani, did you do this one?
Yeah, I got 48 over 120, which I think is 2 over 5.
2 over 5. Okay. Anyone confirming the same answer?
I got 1 over 5.
So
1
I
over
got
5.
I got 2 over 5.
Okay. All right. A few 2 over 5s, a few 1 over 5. Let's discuss. So this is the standard box approach, right? We'll put J and K in a box. And then we'll say there are only 4 seats now, right? So the box takes some seat and the other 3. So L, M, N, and the box, right? They can be arranged in 4 factorial ways. And when you open the box, J and K can be sitting left, right, or right, left. So the probability is this. Just 2 over 5, right? Who was it? Who got 1 over 5? Navya, was that you?
Yeah, I forgot to multiply by 2.
Opening the box. Okay. All right. Makes sense? Fairly straightforward again. Next. That was okay. Handshakes. How many handshakes were there when 8 people enter a room? Yuvam, what did you get on this one?
Sir, I'm not sure on this one, but I think I got 28.
28. Okay. Sanvi, can you confirm you got same?
Yeah.
Sanvi, I heard you, but it's very, very feeble. Can you speak up a little bit, or maybe your mic is not in the right place? I can barely hear you. I heard you say yes, but it's feeble. Just check on that. 28, fairly easy, right? There are 8 people. A handshake happens for any 2 people. If you choose 2 people, a handshake happens. So it's 8 choose 2, as simple as that. So 8 into 7 by 2 into 1, which is 28. Okay. Okay, let me rephrase this another way. Okay, let me ask another question in this one. Let's say there are 8 couples, not 8 people, but 8 couples, and they go to a party. So obviously, you're not going to go to a party and then shake hand with your own spouse, right? That doesn't make sense, right? You're going to meet new people. So each person shakes hands with every other person except your own spouse. Right? How many handshakes will there be? Can you all take 30 seconds to do this?
So can you repeat?
8 couples go to a party, shake hands with each other, except with your own spouse. How many handshakes? Okay, Arav's hand is up. Okay, go ahead, Arav.
it's just, do you say 8 couples or
8
8
couples. 8 couples. 16
Oh.
people.
Okay.
Oh, you raised your hand to ask a doubt, is it? I thought you had an answer. Okay. You don't have to raise your hand to ask a doubt. You can just ask anytime. Okay, Yuvam, go ahead, please.
Sir, is it 14? Because
14
8
handshakes.
8 choose 2 is the same, and since they're couples, divide by 2 because they can't shake their hands with the wife. So it's 14.
I don't understand your logic. What are you saying? 8, where did 8 choose to come from in this case?
Because there are 8 couples,
8 couples.
and each of them shake hands with their like everyone except their wife.
So, okay, so 8 couples, which means there are 16 people, right? You're with me? There are 16 people, you
16.
agree?
Yeah, so sorry, I got 28 then. 28.
So you're saying, okay, it's 28. Okay, again, come again, please, with your explanation.
Because it's 16, and since they can't shake hands with their wife, it's divided by 2.
Where did 28 come from? So what divided by 2, first of all?
16 divided by 2.
16 divided by 2 is 8 though.
And then 8 choose 2 because it's 2 handshakes.
I don't understand the logic. What is this 8 and what are you choosing 2 with? There are 8 couples. When you're choosing 8, choose 2. That means you're selecting 2 couples. You're selecting 4 people. Okay. Randomly, if you just do 8, choose 2, that doesn't make sense, no, Yuvam? What you do must have meaning. Again, I'm just telling it to Yuvam, but applies to everyone, right? Whatever you do, be it factorial or choosing, or just don't do stuff for the heck of it. Understand what's happening. 8 choose 2 kya hai, Yuvam? There are 16 people, divide by 2, 8 couples. If you do 8 choose 2, you're picking 2 couples, which means you're picking 4 people. What will you do with those 4 people? Just imagine the situation. Does it make sense, Yuvam? Does it?
Yeah.
I mean, does it make sense that what you said does not make sense? Again, I might be harsh, but that's how you learn. Yeah. Just imagine. Okay, Navya, what do you have?
I got 112.
112. Okay, explain your answer, please, Navya.
So I did 16 people, so 16 choose 2.
Yeah.
That gave me 120. And then since like each person handshakes with like their own wife or husband, that's 8 handshakes, so you reduce 8.
Exactly. Yes. So if there's no restriction, if the 16 random people going to a party, it'll be like the previous problem. Instead of 8 choose 2, it'll be 16 choose 2. Right, Yuvam? You understand? So there are 16 people. Let's imagine they're all strangers. Then, like the previous question, instead of 8 people, it's 16 people. No different. Now, the only restriction is among these 120 handshakes, I'm forbidding the 8 handshakes of each person with that person's spouse. So I'm subtracting 8, or rather she's subtracting 8, and she's making it 100. Does it make sense? Logically, does it make sense, Yuvam? Does it make sense to everyone? Veer, are you with me on this? Yeah, Veer, you're with me? Oh, sorry. Okay, I can barely. Okay, you're good. Okay, something with your mute, unmute. Yeah. So if your mute, unmute does not work, guys, please use your electronic thing and just convey the message. Okay, all good. Nice. Okay, question 12. Okay. How many 3-digit numbers can be formed using the digits 0 to 9? Bad question. Bad question because it doesn't say repeats are allowed or not allowed, or it's not very clear to me. If I read this question, it's not clear one way or the other. Let me read it again. How many 3-digit numbers can be formed using the digits 0 to 9? Again, I read it again. It could be interpreted either way. I could use, for example, 779 could be a number. On another day, they could say, no, you use 7 twice. It's not. Only 697 is a valid number. Okay, so let's do one thing. Let's do both cases. First, with repeats, allowed. And second, actually first, with repeats, not allowed. Okay, so let's say how many using the digits, no repetition. Okay, so no repetition. Okay, with that, let's do both the parts and then we'll come back. Okay, with no repetition, Suhani, how many 3-digit numbers?
So I did it and I got 720, but I'm not sure because like 000 wouldn't count as like a number. So I'm not sure how to like eliminate the zeros like at the start.
Okay, it's good that you're recognizing, but you don't know how to deal with it. Okay, 720. Okay, this is without repetition. Huh? We are discussing without repetition. So which means 779 is not a valid number, nor is 012 because it cannot start with 0. It's not a 3-digit number technically. Okay, Drishit, do you have an answer on this one?
So I attempted it, but I didn't really get an answer.
Okay, fine. Veer, what about you? If you're able to unmute. Okay, no, your unmute is not working. Fine. If you can chat or something. Anyone else? Navya, what did you get?
So initially I also got 720, but then I just resolved it and I got 648.
648. Okay. All right. Let's solve.
Sir, even I got 648.
648 as well. Okay, cool. Let's solve. Okay, no repeats. So there are 3 spots here. Okay, the first spot can be any number from 1 to 9, right? I can pick any number from 1 to 9. So I have 9 choices. So let's say I fill in the number 6, for example. So this is the number itself. This is the number, and this is the number of ways, right? So I'm putting the number of ways here at the top. So here's an example number. I should say example number. Okay, so I filled 6 in the first spot, and now I come to the second spot. Anything other than 6 is possible, including 0. So of the 10 digits from 0 to 9, there are 10 digits, right? This is 10 digits. 10 digits. Right? Of the 10 digits, anything other than 6, because I've already chosen 6. So I can select 9 ways for the second one. And then for the last one, anything other than the first 2, right? It cannot be 6, it cannot be 4, it can be anything else in this example. So it's 9 into 9 into 8. So that is indeed 648. Well done. Okay. And then you said 648, right? Well done. What about Navya as well? How many of these numbers are divisible by 5? Navya, did you get an answer on the second one?
I got 9. 1 second. I'm not sure where I think I got 180.
180. What about you, Yuvam?
Sir, I got 2 answers. Like I was not sure on which one
Fine,
is
fine,
correct.
fine. Call out both your answers. It's fine.
So it's either 144 or 146.
144 or 146. Fairly close numbers. Okay. Arya?
I got 162.
162. Okay, Arya, can you take us through what you did to get 162?
So I got 9 ways to get the hundreds number, and then
Okay.
I got 9 for the tens. And
Okay,
then,
just like what we did earlier. You
yeah,
mean?
and then but because it's only divisible by 5, it's there are only 2 ways, 0 and 5.
Okay.
So I just put 2.
Okay. Can someone point out the mistake that Arav is doing in this? Not Arav, sorry. Who was that? Arya, right? Okay. Who was answering this? I forgot now myself. What happened?
0 in the middle place, then it can't be 0 again in the last place.
Exactly. Yes. Yeah. Arav, did you answer this or Arya answered this?
I answered it, Arya.
Arya. Okay. So do you understand your mistake? Drishit rightly pointed out.
Yeah.
You understood, right? Because we're dealing with no repetition. If you have 0 here, or if you have 5 here in the first spot, right? Those are all good examples. Or if you have 5 here and 0 here, for example, right? All of that has to be accounted. Okay, so Drishit, how did you account for them and what did you get? Yeah, Drishit. You're muted, Drishit.
Oh, sorry. Yeah, I don't know. I just got the mistake. I'm not sure.
Okay.
Remove all of the
Okay. So sounds good. So let's discuss, right? So here it's tricky, right? If I put 5 in the first spot, I cannot use 5 here, as you rightly said. If I put 0 here, or if I use 5 here, right? Then all of those problems occur. So let's start filling wherever the constraints are. Okay. So where are the constraints in the last digit? So I'll say the last digit is either 5 or 0. Okay. So in fact, to be consistent with what we did earlier, I'll put the digit below this, right? So the last digit can be 5 or 0. Okay. But then here also there's a problem. I cannot treat both of them equivalently, because if I put 0 at the beginning, at the units place, then I'm assured that 0 will not be in the hundredths place, because we are doing non-repetition case, right? And therefore, I'll have to deal with both cases separately. Whereas if I put 5, I still have to deal with 0 being in the first position, or rather 0 not being in the first position. So I'll split it into 2 different cases. So either 5 in the last place, which means I'm locking it to be 5, which means there's only one way, literally, right? Or 0 in the last place, right? Either of these 2. Now, let's do the first one. If I put 5 in the first place, now by the first place, I mean the units place, sorry. Now, when I come to the hundredths place, 0 is ruled out. I cannot start a number with 0. 5 is ruled out because 5 is already consumed. I have only 8 ways. It can be a number like 7, for example. Right? And then when I come to this place, the digits that are ruled out are just 7 and 5 in my example. This is the example. Huh? Okay. So it can be 0, it can be anything, right? So therefore, we have 8 possibilities for this one. So it's 8 into 8 into 1 in this category. What about if I end in 0? Then in a way it's good, right? I can use all of those 9 numbers which are with me to occupy the first spot. And then of course I can choose, well, let's say another example, I'll just give, let's say this is 3, right? I can choose any of the 8 numbers to occupy this next spot. So just to complete an example here, so this will be 705, let's say. Okay. Does it make sense? So this is 9 into 8 into 1, which is 72 ways. And this is 8 into 8 into 1, which is 64 ways. So 72 plus 64 is 136 ways. Right? These are all divisible by 5. Does this make sense? Now we are able to spot your mistake.
Yeah, so I did it initially and then I got 136 later.
Okay, cool. Nice. Yuvam, how about you? You spotted your mistake, 144 or 146?
Yeah.
Okay, cool. You don't have to share. In general, I'm asking. Okay, all of you good? Suhani, you're all good?
Yes, sir.
Okay. Okay, now we are going to repeat the exact same question with repeats allowed. So I'll just say,
But I have one doubt.
yes.
Sir, why can't you do the same thing? Since you got the answer already, 648 in the previous question, you
Yes.
could just, and you know that out of 0 to 9, there are only 2 numbers which are divisible. So
Yeah.
it's 648 into 2 upon 9.
Why 2 upon 9? 648 into 2 upon 9.
Because there are only 2 numbers out of all those 9 numbers that are divisible by 5.
Yeah. So why does it make sense to just take 648 and multiply by 2 by 9? Where are you accounting for the fact that the starting digit cannot be 0 and all that? It's not directly a fraction of that, right? Approximately, it might come out to be that, but it's not obvious that it has to be 2 out of 9. First of all, there are 10 digits. Should say 2 out of 10, if that's what you mean, right? 0 and 5 out of 0 to 9 is 10 digits, right? Yeah, but even otherwise, it's very handy maybe just to say 2 out of 10, right? Yeah, 2 out of 10 are divisible, are the numbers with which you want to end, right? But that doesn't make you can directly say that, use that proportion. Okay, all right. So let's repeat the same question with the repetition allowed. So I'll just say repetition allowed. So now in the second scenario, so which is why the problem is not very clear. Now I'm going to say repetition allowed. But both are good questions, right? We can have with repetition or without repetition. Just that the problem has to be well stated, which in this case I thought is not. Okay, repetition allowed, which means what? I mean, I'm going to allow 727 as a valid number, but I'll still not allow 034 because it cannot start with 0. Okay, now can Sanvi, can you tell me the answer for the first part now? Even if you've not done it, you can do it now as we speak right now.
So is like 777 around?
Oh, good question. Yes, repetition allowed means all 3 also can be said. Yes. In fact, I urge you guys to all take the same approach. Write a few examples and say which are allowed, which are not allowed. That way, it'll help you it'll help you think. Okay, Sanvi, go ahead, please. I'll help you. Yeah, make a start.
Sorry, my mic was off. Can you hear me now?
Now I can hear you very well. Yeah, I was just wondering what's happening. Yeah, go ahead, please, Sanvi.
The first place still can't be 0, so there'll be 9 possibilities, and then for the other 2 places there'll be 10 possibilities.
Excellent. That's 900. There's no surprise. It's essentially asking how many numbers are there from 100 to 999. Literally that, right? 100 to 999. How many numbers are there? The difference is 899, but we know when we add numbers, we have to plus 1, right? So it's 899 plus 1.
So is this so if the thing ends in 7, then it's no longer divisible by 5.
No longer, yeah, we're doing the A part right now. We're doing the A part. We'll come to the B. Yeah, we'll come to the B part. Now, what you am saying will make sense, right? Of the 900, they are all continuous numbers. Every fifth number will be a multiple of 5, right? Every fifth number. So you expect a fraction of approximately 1/5. It might not be exactly 1/5, depending on edge cases, right? We expect an answer of approximately 180. It might be even exactly 180. We'll do it now. But here, it makes sense what you said, because you're talking about a continuous set of numbers from 100 to 900 without any gap, and 100 to 999, I'm sorry. In that, every fifth number you're observing is divisible by 5, right? In fact, it'll be exactly that, because it's 100, 101, 102, 103, 104. That's a set of 5. In this, exactly this one is. If I read the next one, it'll start with 105. The next one will start with 110. And the last one, 990, and then 995. Starting with 995, you get a set of 5. So you have a symmetric rectangle of whatever, how many ever rows there are. I don't even care. In fact, I do care. That's exactly what I want, right? So it's 180. And there is 5. 180 into 5 is 900. So the answer would be 180 in this case for the second part. Does it make sense? Why it makes sense in this case?
Yeah.
And it's 1/5. It's 2 out of 10. Yeah, but good thought there, right? Taking a proportion there. Yeah. Okay, all of you good? Drishit, were you able to find your doubt from last class?
Also, I didn't really have any specific doubt. Just
But in general, the concept, right?
yeah,
But slowly
better.
it'll become clear. Don't worry, right?
Yeah.
So as you do a variety of questions, things will become clear. Again, my main thing is 1 or 2 things, right? Just visualize. Close your eyes. Don't be forced to putting factorials and 8 choose 2 and 6 3, whatever, right? Just because it sounds sexy. Don't do that. Just put yourself in that situation and close your eyes and just imagine what's happening. And the rest will speak for itself. Okay? All right. That was question 12. Okay, question 13. One second, let me just, I may not able to. Okay, 2 points, sorry, 10 points are located on a 2-dimensional plane, such that no 3 points are collinear. Collinear means co-linear. Same line, co is same, linear is line, right? No 3 points are on a straight line. That's the question. How many line segments joining 2 points can be drawn? Suhani.
I'm not sure, but I think it's like when they say 10 points, they mean a decagon, because I got 45 line segments for that.
Yeah, exactly. There are 10 points. Any 2 I choose, I'm able to draw a unique line. So it's just 10 choose 2, which is 45 indeed. 10 into 9 by 2 into 1. Why? You should be more confident. Yeah, it is that. Stop saying I'm not sure. I mean, right? Yeah, it is right. It is right. 10 choose 2, which is 45. Okay, B part. How many different triangles can be drawn by connecting all 10 points with line segments in every possible way? Okay, Arav, what do you think?
So if it's a triangle, then it's just 3 parts. So it'd just be 10 choose 3.
Exactly. Just like you have to choosing 3, you're choosing, just like you were choosing 2 in the previous part, you're choosing 3. So it's 10 choose 3. So 10 into 9 into 8 by 3 into 2 into 1. So that comes out to, I think, 120. Okay. Okay. But let me ask you one question, right? So suppose I use my first part, right? The 10 points are randomly here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, something, right? And I draw a line in one of the 45 ways that Suhani said, right? I'll pick these 2 points. Let's say I'm drawing a line, right? Now, so that's 45 ways. And then I get to choose any one of the remaining 8 to form a triangle, right? So it's 45 into 8, which comes to 360. Why am I getting 360 now instead of 120? You understand the confusion? I'm planting a confusion for you to justify why this is wrong. But what I'm doing is, back to what Suhani was answering in the part A, she picked any 2 points in 45 ways. Having done that, she picks a third point. There are 8 more points left. 1, 2, 3, 4, 5, 6, 7, 8. She can end up choosing, let's say, this point and say, this is the triangle. She completes it. So if you look at it this way, 45 into 8 is 360. Why are we getting two inconsistent answers?
Wait, is it because you're like counting it again?
Where is it getting counted again?
Like for each line, you count it as one triangle, but it's just one triangle by itself. So
You're right, but can you expand exactly where the double counting is happening? Can you expand on that?
I'm not really sure how to explain it, but like the triangle is getting counted 3 times for each line, but it's just one triangle. So
Exactly. Yes. Yes. Because in another situation, I'll be counting, let's say these two as the line, and I'll count this as the third point. I'll say this is the line, right? So depending on which two I pick first, right? That's 45 ways, and the third one is into 8. But effectively, it's the same triangle as you rightly said, right? And so among the 3 points, I can pick a pair in 3 ways: AB or BC or CA, right? Which is why it's getting repeated thrice, and therefore it's 360 by 3, which matches with 120. Makes sense, right? Yeah, all of you good on this? Arav, you're okay? Okay. Were you able to fix your mic, or you're still struggling with that? Still not okay. Okay, fine. Okay, question 14. 8 people enter a room and sit at random 8 chairs. Okay, we can make up a few different questions in this. Okay, first let's do this straightforward question. How many ways can C, R, and J sit together? Okay, we have done many questions by now. We should be able to tell this. Sanvi?
Sir, I didn't see the 14th and 15th one.
Why? Was that in a different page?
No, sir.
Okay.
My laptop just.
I say bhul gaya. Okay, fine. Drishit. Okay, do it now as we speak. Drishit.
So I haven't done.
Okay, I'll give you guys 30 seconds. This is all 30-second question. You don't even need to simplify and give a numerical answer. You can leave it in factorials and this thing if you want. But if you can't tell it, that's good. Okay. Just hold on 1 second. These guys who have not done it, I just want to give them 30 seconds to do it once, and then we will compare answers. Oh, okay. Veer, I'm just seeing your chat only now. Your mic is giving an error, trying to figure out. Okay, sorry. I'm just seeing it now. Okay. Drishit, anything?
So 1 second.
Okay, Sanvi.
So I got 144. I don't think it's right.
144. Okay. Yuvam, what did you get? Yuvam.
So
Your hand was up, so I thought, don't be influenced by her answer. Your answer, I mean, she might be way off, right? Who knows? You call out your answer, whatever you get, it's fine. We'll discuss.
I just realized I got an answer in fraction, which is not possible.
Okay, it's not a probability question, it's permutation question, right? Okay, Arav.
So I didn't simplify it fully, but I got 7 factorial times 4 factorial.
7 factorial times 4 factorial. Okay, let's do this. There are 8 people. 1, 2, 3,
So
4.
also I got 120. So
You got 120.
yeah.
Okay. It seems very small number, no?
I got
Okay.
Yeah.
factorial into 3 factorial.
Navya, what did you say? Please repeat.
I got 6 factorial into 3 factorial.
6 factorial into 3 factorial. Okay. Anyone else? I heard one other voice. Arya.
I just got 36.
36. These numbers seem very small. If there are so many people, you would expect lot more combinations. Okay, so let's do this, right? Again, very similar to what we have done. So these three you want to put in a box. So C, R, and J, let's pack them in a box, and then we'll open the box later, right? So now there are only 5 remaining people, right? There are only 5 remaining people and this box. So I'll just 1, 2, 3, 4, 5, 6. So there are 6 spots essentially. So 6 factorial ways in which I can arrange, including the particular box. Open the box, arrange C, R, and J in 3 factorial ways. As simple as that. It's perfect, Navya. Yeah, makes perfect sense. Whoever said 7 factorial times 4 factorial, was it a counting mistake? Because it seems like you had the right idea. Who was that? I forgot. Arav, was that you?
It was me. So I just put it in a. I don't understand what I did wrong, because I just treated 3 sisters as one unit, one entity.
Correct.
So then in total there'll be 7 entities, right? Because
How
if I
7
treat-
entities?
because
These 3 are together. They still need 3 chairs, right? And the remaining 5 friends and this one, therefore the 6 entities. Right?
Yeah.
But even assuming that mistake, that explains the 7 factorial. Where is the 4 factorial coming from?
So the 4 factorial was because since I treated the 3 sisters as one unit, then
Yeah.
I got, so the 4 factorial, so since there are 4 other people, right?
4 other people.
Apart from the sisters.
Yeah, but you're accounting for them in the 7 factorial anyway. Are you not? If you're arranged, yeah, those 7 are, I know it's a mistake to say 7, it's 6, but whatever way, even with that mistake, that 7 factorial accounts for arranging the remaining also.
Yeah. So
Yeah.
I understood what I did wrong.
Understood, right? So it's pretty straightforward, as she said, right? 6 factorial ways, right? And then open the box, 3 factorial ways. Okay.
Yeah.
All of
So
you good on this? Yeah.
I did it like this. There are 6 ways they can sit, and there are 8 rows. So 6 into 8, and then there are 3 people
No, please,
multiplied by 3
slow down once more. There are 6 ways in which they can sit
in
amongst
one
themselves.
row. In one row. So and then there are 8 rows. So I just multiplied 6 in.
No. There are no 8 rows. There are 8 chairs in the
Oh.
row. There's only one row of 8 chairs. That's it. There's only one row of 8 chairs. There's enough, as many chairs as there are people.
Wait, so would it just be 6 into 3? Because there are 6 different ways they can sit and 3 people.
No, there are a total of 8 people. Read the question. There are 8 people, of which the 3 sisters need to sit next to each other. 8 people, 8 chairs. So enough. So exactly matching the number of people in the chairs. And 3 specific people have to sit next to each other in that row.
Okay.
Yeah, I think the question was fairly clear. I think you're interpreting a lot of things which is not even mentioned in the question, right, Sanvi? I can understand some questions which are vague, but this question is fairly
I read it wrong.
crisply framed. Yes, Drishit, you had a question. Was it you?
Yeah, so can you explain the 6 factorial into 3 factorial again?
Sure. Okay. So C, R, and J need to sit next to each other. Correct? Now, let's pack them together in a box. They'll always travel together. They'll still need 3 seats, but they'll be together. So in that situation, effectively, I have only 6 spots. There are 5 other friends, and then these 3, for example, let's say I'm putting them here. It means it's 3 consecutive locations in this particular spot. Effectively, they're taking 3 spots still. Does it make sense? So these are other people. Let's say this is A, this is C,
forgot
this is D.
I forgot to count that they 3 can also switch inside the box. Yeah.
Okay. Now I'm going to give a few variants of this question. So the first variant is they should, how many ways says that? They should not all sit next to each other. Okay. Can someone explain to me? Veer, this thing is still off, right? I'll ask Suhani to explain. What does this mean to? What does this mean to you? In how many ways can they sit such that they should, these 3, I'm talking about C, R, and J. They should not all sit next to each other. Suhani, can you take this?
So it could mean that C and R can sit next to each other, but J can't sit next to them.
Exactly.
So like
Yes.
it's
Yeah.
still possible for two of them to, but not all in the same rows.
Perfect. Yes, that's the correct interpretation. And that's what this sentence is also correct. They should not all sit next to each other. As she rightly said, two of them can sit next to each other, but the third one should be slightly away because they cause a ruckus if they're all sitting next to each other. Now, how many ways? Can you all work out?
So isn't it just the total number of ways minus the last?
Exactly. Yeah, the total number of ways, which will be just 8 factorial. Thanks for calling it out, but I thought I'll just give some people some time. Okay, so it's 8 factorial was the total. The only case where you don't want is all of them sitting together, which you already solved, which is 6 factorial times 3 factorial, the previous answer. Right? Does it make sense? Yeah? This is the only case which you don't want, which of course you can simplify if you want. I can take 6 factorial common outside, and then this is 7 and 8, which is balance, and this is 6, 3 factorial. So I can write it as 6 factorial times 50. Okay, that's simplification, but conceptually was that. All of you okay on this one? Now, another variant. I'll say none of these 3 should be sitting next to each other. So I'll say none of them. So I'll say in red, none of C, R, J should be adjacent. Okay. So I'm being even more restrictive. So earlier, right, I was okay with 2 of them sitting, but the third one should not be. Now I'm saying even 2 of them should not be sitting next to each other among these 3.
Again, over here, wouldn't it just be the same thing, but then you subtract the both the answers we got previously?
Which both answers? First answer was
One where all 3 of them are together, and the one where both like only 2 are together.
no.
No.
The answer, okay, one all together was the 6 factorial times 3 factorial,
Yeah.
right? Not all together was the total minus 6 factorial times 3 factorial. Now, what are you saying? So the total ways was 8 factorial.
One where only 2 are allowed to sit next to each other. But now we don't even want that.
Correct.
Yeah. So
Sorry, Drishit. So what are you saying? Okay, you understood the question, right?
yeah.
Oh, okay, cool. Okay, now, yeah, work on it. Please don't call out the answers, whoever is able to. Let me just see like who I should give this chance to. Ideally, I would have given to Veer if his mic were working, because he has not answered today at all. Okay, Sanvi, can you take a shot with this? You have to unmute first of all. Unmute. Yeah. I cannot hear you still. No, I cannot hear you. You're unmuted, but I cannot hear you. Okay. Meanwhile, Arya, anything from your side?
I'm not sure with this.
Okay.
So,
Navya, what about you?
So even I didn't get it.
Okay. Do you guys need 30 more seconds? Think about it, then we'll discuss. Anyone close to finishing? Yubam?
Or my method is very long. I'll take time.
Okay. All right. Let's discuss. Okay. So now, what am I saying? None of these C, R, and J should be next to each other, right? So let me first seat the rest of the people. I have 5 seats, 1, 2, 3, 4, and 5. Okay. Let's say my other people in the class are A, B, X, Y, and Z. Okay, so I'm seating them randomly. A is sitting here, B is sitting here, X is sitting here, Y is sitting here, Z is sitting here somewhere. Okay. So I first make these guys sit. Okay, and then I say to C, R, and J, there are these 6 spots available. You go and pick any 3 and then seat yourself. You're able to visualize this, right? So first of all, these X, A, B, X, Y, and Z are sitting in 5 factorial base. After they are seated, just imagine you can insert seats anywhere, right? These 3 people, the 3 sisters, choose which 3 they are going to be sitting. Let's say they end up choosing this spot, and this spot. Having chosen, they decide who is sitting where among those, which is 3 factorial base. Does it make sense? Logically, does it make sense? Rest is simplification, which anyone can do. All right. So if at all we have to do, it's 5 factorial into, what is the 6 factorial into 3 factorial into 3 factorial. This 3 factorial will cancel. Okay. I'm not going to simplify this. 5 factorial into 6 factorial by 3 factorial, but you guys should be, they're all still small numbers only. Should be able to do by hand if it comes in the exam. So in fact, I keep saying I'm not going to do, but let's do this. So this is 6 factorial will cancel off, giving 4 into 5 into 6. Right? And then there's 5 factorial, which is 120. So it's 120 into another 120, which is 14400. If I did not do some silly mistake, it's that. Okay, but again, I'm trivializing simplification. It's extremely important, guys. After doing all the hard work, you cannot mess up that. But concept is more important. And right? Does it make sense? What I described here? Anyone not clear?
Yeah.
Yivam, you're okay? Drishit, you're okay?
So no, I have a doubt.
Yes.
So, but I didn't, I understood this, but I didn't understand why you can't just, like, so basically in the original question, it's asking us how many ways they can sit all 3 together. And then the,
Okay, I'll list out everything we studied so far. Okay, so first was no restriction at all. So let's start with no restriction. So there was no restriction at all. How many ways do you think, Drishit? 8 factorial ways?
Oh yeah, 8
8
factorial.
factorial ways. Okay, now C, R, J, okay, together.
Yeah.
So that was the actual question here, which is 6 factorial times 3 factorial. Okay, and then I said not all of C, R, J together. So
Yeah.
for this, we did 8
But
factorial minus 6 factorial times 3 factorial. Now this is the 4th case where I'm saying C, R, and J, none of them can be sitting next to each other, right? Should not
yeah.
be next to each other. Okay, whatever. Okay. So this is the 4th. Now what are you proposing? You tell me for this. So you did not understand why you could not do what? Complete the sentence.
Yeah, so I know that over here the 8 factorials cancel out, but then why can't you just add both the situations where they are together and only 2 of them are together, and then subtract that with the no restriction? I mean, the 8 factorials do cancel out, so but I didn't understand why.
Oh, okay. So you're
Yeah.
saying from the no restriction, subtract off the case that not all are together.
Yeah.
Okay, and then so why are we subtracting not all together?
Because that's another case where, because over here the question is that none of them should be together.
Correct. So in fact, not all together will be a superset of this, right? So why are you subtracting that? So for example, an example for not all together would be where an example for this would be let's say A, B, and C, right? So A, B, C, R, X, Y, Z, J, right? C, R, and J are the girls, right? C, R, and J are the sisters. They are not all sitting together. Another example for the same case is A, C, B, R, X, Y, Z, J. In this case, neither C nor R, they are all not sitting next to each other at all. This is an example for this also,
Yeah.
but both are examples for this.
So
one.
that's included, and that's why yeah, okay.
Does it make sense? So
Yeah.
what I'm saying is the last one is a subset of the previous one. Does it make
Yeah.
sense? So it's not like, okay, anyway, you're in agreement, right? But good. Yeah, that's how we should think. Nice. Okay, that is question 14. Question 15. Okay, a game is played in which the wheel is spun by the player and the game operator. Okay. Okay. Any answers for this one? Arav,
Yes,
yeah.
sir. I didn't get an answer, but I figured that the first way to do is to figure out the probability of the player winning.
Tell me, what is the probability of the player winning? So probability of player winning is how much?
I got 5/16.
5/16. Okay. Does anyone else get the same answer? 5/16 says is the probability of the player winning. Suhani, what did you get?
I wasn't really sure how to do this question.
Okay.
either.
Navya, what did you get? Player winning.
I didn't get this question.
Okay. Anyone else? You No? Okay. Arav, Arya. So Arav was the one who called out this. Arya. No? Okay. So what are the options? So forget about player or operator. What is the probability of getting a 1? It's 4 out of 8 spots, right? The 4 out of 8 chance for anyone to get it. It's the same game for, it's the same spin for either the operator or the player. Probability of getting a 2 is 3 out of 8. And probability of getting a 4 is 1/8. Okay. Now the player wins if their spin is higher than the operator. Okay. It strictly has to be higher, right? If it's equal also, he's not going to win. So the only combinations in which the player will win, so this is the player and this is the operator. So for the player to win, he must score a 2 and the operator must score a 1, or he must score a 4 and the operator must score a 4, or he must score a 4 and the operator must score a 2. Right? In essence, he must score a 2 or a 4 and the operator must be strictly less than that, namely 1 or 2 respectively. And then now it's question of finding the probabilities for each of these cases. So iska kitna probability hai? The player must score 2, which is 3/8. And this guy must score 1, which is 4/8. So it's 3/8 into 4/8. 3/8 into 4/8. I'm just multiplying the fractions and not the numbers, right? Whatever is in green. And this one, he must get a 4, which is the probability 1/8. And this guy must get a 1, which is 4/8. And the last case, he must get a 4. And this guy the operator must get a 3. So it's the product of these 3. So it's 64 in the denominator. 3 into 4 is 12. Plus 1 into 4 is 4. Plus 1 into 3 is 3. So if I'm doing some silly mistake, please spot me, guys. Stop me right away. 19/64 is the probability that player wins. Correct? Player wins. Player wins only if he is strictly greater than the operator. Because that's what the question says. Spin is higher than the operator. Okay. So now, what will the player think? The player is thinking, I am paying K dollars to pay. So the player is coming with some money, right? So because he spent some money, let's look at his profit after playing this game, right? As soon as he enters to purchase the game, he has lost K dollars already because he's paid K dollars to play the game. So he's down K. And with a probability of 19/64, he will win $8. Because if he wins, he gets $8. Right? Now, for it to be a far game, his net profit must be 0 by weighted probability, right? So he's surely losing K. And with 19/64, he'll get back A. So this must be 0, and rest is simplification, right? I can take the K to the other side and just write 19. So K should be 19/64. So in other words, if he's being promised $32, right, is his winning price, that means the cost for playing that would be $9.5 to play that game. So he pays $9.5. If he wins, he gets $32. It's a fair game. Right?
So
Does it, yeah.
I didn't understand why the total like then if it's supposed to be fair, then how is it 0?
Yeah, so that's what fair is, right? If by probability he's making money, then it's advantageous to him. If he plays millions of times, he'll make a fortune.
Right.
On the other hand, if it's by probability, if he's making something less than 0, then it's
There's
the
not.
operator is gaining. Yeah. So for it to be a fair game, neither of them, right? So if it's purely a mathematician player and a mathematician operator, if the game is structured such that it's not this 19A equal to 64K is not valid, one of them will be reluctant to play. He'll say, no, it's biased towards you. Or this guy will say, no, it's biased towards you. If 19A equal to 64K, both will agree. Okay, now it's at least fair game worth playing.
So I didn't understand 19 by 64A. Because A is the money, right? Like A is how much he's earning. But then
A is the prize money. A is the prize money.
Yeah, so you're not dividing the prize money into that many parts, right? That's a probability.
Correct. So on an average, how much is he? For example, forget this problem. Let's say someone says, right, you're playing a simple tail or a head, like a coin toss, right? If you get a head, you will get $5. If you get a tail, you'll have to give me $1. On an average, how much will you win? Half into -1 plus half into 5, correct? That's how you do it, right? With half chance, you'll lose -1. With half chance, you'll get 5.
Oh, yeah.
So here, exactly same case. In fact, I should say 1 times K. With 1 chance, I am losing K. I have to play the game. So this, with 1 probability, I'm losing K for sure. With 19 by 64 probability, I'll win A. And can that compensate for it to make it to 0? That's what this relation is. Does it make sense, guys? All of you?
I got it now.
All got it now? Okay, cool. Nice. Okay, let's go on to homework 2. Not homework 2, I meant homework 6, the second homework for today. Okay. Dessert chef prepares dessert every week. Okay. Veer, your audio is better or still no? Okay, fine. Sanvi, what did you do on this one? This is the first question. You could not have skipped, guys, saying it was the end of the paper and all that. Who was that? Who gave me that reason? Someone gave that reason. Okay, fine. Sanvi, I cannot hear you still. No, baby. Okay, Arya.
I got 972 for this.
972. Okay.
Yeah.
Oh, go ahead, please. What did you do? Tell me.
So for the first day, Sunday, it can be any of the 4.
Okay.
So I did 4.
So okay, let me just Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Okay. All right. First day can be any one of the 4, is it?
Yeah.
Okay. Why one of the 4? Oh, 4. Yeah. Okay.
There's 4.
Cake, pie, ice cream, pudding. Okay. Yeah.
Yeah. And then on Friday, there's only 1 because it has to be cake.
Okay.
And then all the other days, there's 3 choices because it can't be the one on the previous day.
3,
So
3,
that's what I-
3, 3,
3.
3. But
Yeah.
why would the first day be any special? Okay. Oh, starting with Sunday. Okay.
Yeah,
All right.
starting.
But you're making a mistake. So
Can
what? Yeah, go ahead.
I think I found a mistake.
Yes, what is the mistake, Yuvam? Go ahead, please.
Sir, on Thursday it needs to be 2 because it cannot be cake or it cannot be what was made on Wednesday.
Yeah.
So it's 4 into 3 into 3 into 3.
But wait. Why couldn't Wednesday also be a cake in which it can be a 3, no? Wednesday could also be a cake. Wednesday could be same as the Friday cake.
Oh,
Yeah. Okay. Suhani, yes.
I think the mistake is that like the 4 should be a 3 because it's still like Saturday is like still the day before. So there can still only be 3 options because it can't repeat.
Yeah, but he's saying he's starting with Sunday. So in a way, he has freedom because he's starting the week with Sunday, right? So there's nothing before that. It's only 1 week. So there's nothing before that that's holding him. Right, Navya?
So I still like I didn't start it with Sunday, like even though it says it in the question. I just said that like they said Friday you can only have cake, right? So I just
Yeah.
put one for them. And the rest everything else is 3. Like I didn't
Exactly. Right? There's a subtle difference between what she explained and what you started off with, right? So cake is frozen on Friday. That's 1. Okay. Now, even though the final timetable will be published starting from Sunday, let's figure out from where the constraint is. Friday is a cake. Therefore, Saturday can be any one of the remaining 3, and Thursday can be any one of the remaining 3. I don't care whether Thursday and Saturday are same or not. They cannot be cakes. That's all I know. And then going back, it's 3 into 3, the same thing, right? So 3 into 3 into 3 into, go back to, and now you publish this. After you publish, how do they know whether you started writing Sunday first or you started writing Monday or Tuesday or Wednesday or Friday? They don't care. All they know is there's a cake here. And then whether you started writing here doesn't matter. I'm publishing this. So the table will read Sunday all the way till Saturday. So it's therefore 3 power 6. Does it make sense, guys? Arya, you with me? Arav, you're with me as well? Okay, cool.
I didn't understand the last explanation.
Okay. Right. So she's saying the constraint is on Friday. Right? In any problem, that's how you approach. Where divisibility by 5 means what? The units digit is where we have to worry about. 3-digit number means the hundreds place cannot be 0. Wherever there are restrictions, fill those first, address them first. Then you have bindas, your complete freedom to do whatever you want after that. So here, the restriction is on Friday. Fix your cake on Friday. Choose anything other than that on the previous day, on Saturday, the next day. Choose anything other than that on the previous day. And then going back, anything other than that, anything other than that, anything other than that, all the way till Sunday also same thing, anything other than that. Right? And then once you publish, that's it, right? So the timetable looks as if it's Sunday, Monday, Tuesday, all the way till Saturday. Right? But we internally have started off with Friday and worked out this timetable because that's where the restriction was.
Yeah, but then because it's starting on Sunday, I mean, because it's starting on Sunday, isn't that like a new day, new start? So you can do anything.
Yeah, I can do anything. But if I start with Sunday, the problem comes, I can start with anything. He's starting with anything. And then he's saying anything other than this, any of the 3, any of the 3, any of the 3.
Because on Monday, you can't do this thing you did on Sunday.
Correct. Which is why the 3. So that's what first explanation was, right? Sunday I'm starting. So I'm starting off Sunday without any restriction. I agree so far. And then Monday, it cannot be that. It cannot be that. Now where am I? Right now, Sunday, Monday, Tuesday, Wednesday, Thursday. Sunday, Monday, Tuesday, Wednesday. Now I'm Thursday. Now it can be anything other than that. Now I'm stuck. What if this guy happens to be a cake?
Yeah.
This is Thursday. But I want my Friday to be a cake. So it becomes a problem here, right?
Yeah.
Which is why I cannot take this approach of starting with Sunday.
Oh, okay. Yeah. So then.
It may be cake, it may not be cake. But if there are some cases where it's not going to work out, I cannot use that approach, no?
Yeah. Okay.
Yeah. Okay, cool. Question 2. How many even integers between 200 to 700 whose digits are all different and come from the set 1, 2, 5, 7, 8, 9? Digits are all different. Okay, fine. Okay. Any answers, guys? Yeah, Arav, did you get anything on this one?
So no, I wasn't actually able to attempt the whole homework. I've been down with the flu for the past 4 days.
Okay, Suhani, what about you?
I got 12 integers.
12 seems a small number, no?
So even
I
I
also got 12.
Oh, is it? Maybe it is that. Okay. All right. Let's see. 1, 2, 5, 7, 8, 9. Okay. How many even integers? Between 200 and 700. Okay. With all digits being, oh, okay. All right. So which are the even digits, guys? 2 and 8 are the only even digits. 1, 5, 7, 9 are the odd integers, right? So we have 3-digit number. Now we'll have to pick 2 here. Let's do 2 different cases. Or we have to pick 8 here. Okay. If we pick 2 here, okay. Now the starting digits. So this can be like all the way from 200 something to 699, right? So the starting digit can be 2, but now it's ruled out because we've already consumed 2. The starting digit can only be 1, 5. That's it, right? It's 1 or 5. That's it. So there are only 2 ways, right? This is 2. There's only 1 way. Am I right, guys? The starting digit. The starting digit cannot be 1. What am I talking? It's only 5, right? Only 5. I'm sorry. It's only 5 because it has to be between 200 and 700. So its starting digit has to be only 5. So it's only 1 way. And then the Beachwala digit can be any one of the remaining 4.
But the starting digit can also be 7, right?
No,
Oh, no,
but it'll go be let's see 700, right? Yeah. So it's 4 ways here. And then if the ending digit is 8, then the starting digit can be either 2 or 5. 2 or 5, right? 2 or 5. Okay. And then the same thing for this one can be any of the remaining 4. Okay. Yes. So it's indeed 12 ways. Okay. Suddenly I thought 12 is a small number. Okay. That's 12. Round robin. Okay. Let's read this question together once. Round robin, you guys know, right? Every guy plays every other person. So there are 6 teams. So totally, how many games will there be? Yuvam, how many games will there be in this?
Sir, I didn't do this question.
No, forget doing this question. I'm just asking you a simple question. There are 6 teams, round robin. How many games will be there in the tournament? Forget about the rest of the question.
Each team plays 1 game, so the team. So it'll be 6 factor, not 6 factor, 6 plus 5 plus 4 plus 6 plus 2.
5 plus 4 plus 3 plus 2 plus 1. Right? So 1, 2, 3, 4, 5, 6. 1 plays against 2, 1 plays against 3, all the way to 1 plays against 6, which is 5.
Oh, yeah,
Plus
because
4. Yeah.
6 teams play 5 games, yeah.
5 plus 4 plus 3 plus 2 plus 1. But why do that? Now that you know choosing, it's 6 choose 2. I can pick 2 from 6. So 6 choose 2. So, but both of them will be same. 6 into 5 by 2, which will be 15 games. Okay, 15 games of the tournament. Each guy plays with each other. Now, what does he want? Each game results in 1 team winning and 1 team losing. There's no tie or draw. Okay. At the end of the tournament, the teams are ranked by the number of games won. So let's say 1 point for winning, 0 point for losing. What's the maximum number of teams that could be tied for the most wins at the end of the tournament? Okay. So can all 6 teams have the same score at the end of the tournament?
No,
Why
they
not? Yeah, go ahead. Why not, Navya?
15 isn't like 6 isn't a factor of 15.
Exactly. So 15 by 6 is not an integer, right? So not all can have the same point at the end of it. Okay. Now let's work backwards. Can 5 people have the same score? Suhani, what do you think? Can 5 people have the same score? Will that work in this case?
Would it be, yeah, because it's a factor of 15, so it can be.
Oh, yeah. No, 5 is a factor of 15. It doesn't mean that all 5 of them have to consume all the 15 points, right? The 6th guy can also get somewhat a lower point, right? Yeah, so 15 by 5 is 3. I agree. But you're forcing that the other guy, the 6th guy, does not get any point. That need not be the case. But anyway, to answer this question, yes, it's possible. But it need not be that all of them got 3 points. All of them could have got 2 points. But then in that case, the last guy would have got 5 points, which doesn't make sense, right? The last guy should be the worst guy, right? But yes, so 15 by 5 equal to 3. But just because 15 by 5 is an integer, it doesn't guarantee that this will always be possible. Can you devise a particular outcome where each of these 5 teams will end up getting 3 wins. You're understanding my question, right? So first check is whether it's an integer. Okay, that check is passed. But just because it's an integer, it doesn't guarantee that it's possible, right? You might not be able to achieve a certain outcome by which each of these 5 teams gets 3 points each. So you have to give me a particular example scenario where that's possible, if at all it's possible.
Would it not
But-
just be where the 5 team, like they win 3 and then the 6th one doesn't get anything?
But is it possible that every one of those A, B, C, and A, B, C, D, E, all of them win exactly 3? Is that possible? That's all I'm asking. So give me an example. I'm saying all I'm saying is give me an outcome. A defeats B, A loses to D, A wins F. Something. Give me an example like that, right? Where this will be ensured. That's my question.
I'm not too sure like how to come up with one.
Okay. What about you, Navya? Navya, you're on mute. On your video off. You're on.
So
Okay.
basically, like if if F loses all of their matches,
Yeah.
A, B, C, D, E, then won't it be possible?
Yeah. So tell me. It will be possible, but give me an example, right? Where, or give me a. I don't know how to describe it, right? Give me a scenario where it will be possible.
A wins against F.
Okay, A wins against F. Okay, so F, we agree, was the worst guy. He's losing against all of them. So all of them will defeat F. That we all agree. Okay, he gets 0 points. A wins against F. Then what else?
Then B wins against F. C wins against F.
Yeah, so we agree that everyone will defeat F. So each one of them has fetched 1 point by that. Now each of A, B, C, D, and E must get 2 points more. How are they going to get that?
Yeah, so A wins against B, B wins against C, C wins against D, and D wins against E.
And E wins against A.
Yeah, and E
So
wins.
that's 1 point. And then?
And then A wins against C, B wins against D, C wins against E, and then D wins against A.
Okay. And then by that same logic, now A can win D also, or so you're.
No, D wins against A.
B, I thought you said A defeats B.
A defeats C, B defeats D.
Okay.
C, E, and
Okay.
then
Okay. I thought in addition to A defeating B, A defeats C also. Or you said that or.
that's true.
Okay.
Both of them.
Both of them, right? Okay. So what probably that's what you meant. So basically it's easy to draw like a diagram. Sorry. So something like, let's say we can draw them as a pentagon, right? A, B, C, D, E. So we all agree will defeat F, which is a minnow team, right? Everyone will defeat. So we can agree that every guy going in clockwise direction will defeat the 2 neighbors in the clockwise direction, but will lose against the 2 neighbors before him, right? So this rotation can, so A defeats B and C, B defeats C and D, C defeats D and E, D defeats E and A, E defeats A and B. So that way the cycle completes. It's symmetric. So I've given an example where if I take A, B, C, A wins. Sorry, A defeats B and C, A loses to D and E. To the right, it wins 2. To the left, it loses 2. And this balancing act works throughout the circle. And therefore, 5 people can make it. Does it make sense? Probably that's what you meant. And probably Suhani, I don't know whether you had probably also had the same idea. We're not able to express it, right? But yes, we are in agreement right now that 5 teams can win with equal points together. Yeah, Arav, you had a question?
Oh, so sorry, I have to leave now.
Yeah,
Is that
yeah, that's fine. I was going to end class here as well. We are almost done. So yeah, so I think pretty much we are done with all the concepts. From now onwards, it'll be topical questions. So I'll come up with the homework. And sorry for the, yeah, leave Arav, it's fine. You can catch up on the last 1 minute in the video. So I'll just send out the homework a little on a timely fashion. I think last time I sent it out very late, Wednesday or Thursday. You guys might not have had enough time. Apologies for that. Okay. We'll meet next class. Chalo, bye. Oh, sorry, Veer, I'm just seeing your chat. I got 729 different menus. Oh, okay, that's 3 power 6. Okay, cool. Check on your mic, Veer, please. Okay, bye.